So thank you everyone for joining in this session. I'm going to talk about the interrelationship of marine spatial planning to the spatial patterns of coral reefs. Next slide. And in my introduction, I would like to point out the importance of coral reefs. It is common knowledge that they are highly biodiverse ecosystems and they offer a range of ecosystem services. And these include tourism as an industry. It brings in billions of revenue, and also coral reefs offer coastal protection and also as a source of food production. The most important thing here is that the coral community are the ones that maintain the integrity of a coral reef. And once we lose the coral community, then we lose the function that a coral reef brings in. So we have to maintain the coral community in order to enjoy the functions provided by the coral reefs. And next slide. There has been an alarming degradation of coral reef all over the world. And here I would like to show you the process that coral reefs undergo into degradation. So once we have a healthy reef and then a perturbation occurs or a disturbance occurs, the healthy coral reef, which has high cover and structural complexity, we lose the coral community and we get a degraded reef. Normally, a degraded reef is possible to recolonize and go back to a healthy reef. However, sometimes if the recolonization does not happen quickly, then other substrates colonize the area that were covered by corals. In this case, mostly it's the algae. And once the algae recolonize this place, we get a dysfunctional reef where it is algae dominated instead of coral dominated. And in this case, several studies have found that it is difficult to reverse a phase shift. So it's very important to keep coral reefs have coral dominated and avoid a phase shift. Next slide. So in terms of the environmental pressures to coral reefs, I will only focus on 3 because yesterday we have an elaborate session with Dr. Obura pointing out the various environmental pressures to coral reefs. So for my talk today, I'll focus on the 3. And these are normally pressures that affect the coral community. They kill corals and we lose the integrity of reefs from these pressures. So first one is climate change. Climate change causes increases in sea surface temperatures, and in this way, the corals are get stressed, and they die. And climate change has been causing more frequent and severe bleaching to coral reefs recently, and there's danger of losing the coral community from climate change induced bleaching. The second one is sedimentation. We get sediments mainly from river inputs. We get sediments mainly from river inputs, and in this way, the sediments smother and kill corals. By covering corals, they limit the light penetration for a coral function, and in this way, they kill the corals. The third one is pollution. Normally, pollution affects the water quality, and this hinders the growth of corals. And another form of pollution is through nutrification. Too much nutrients in the water column can cause growth of unwanted algae on the substrate, and this way the algae takes over the space that is occupied by corals, and then we have an algae-dominated reef instead of a coral-dominated reef. Now these 3 environmental pressures the climate change is from global sources, and sedimentation and pollution are caused by sometimes regional or local sources. And these sedimentation and pollution, they are within the reach of managers to control. But climate change is outside the reach of managers to control. So it makes it even a more threat because it requires global solutions to handle it. So it poses a very big threat to coral reefs. So these threats also don't work in isolation. Sometimes they work together in synergy or in additive way, and we have climate change causing bleaching, then sedimentation settles in, further degrading or further stressing the corals, and then in addition pollution, we get a mixture of pressures to our reef community, and in this way, it becomes a huge problem. So if managers can reduce sedimentation and pollution, then we only have climate change to deal with. Maybe we can reduce the pressures in that way. Next slide. I would like to talk through the three pressures one at a time. Climate change in Kenya has been causing coral bleaching, and the most profound bleaching was in 1998, where we have mass coral bleaching killing 50 to 70% of coral communities across the country. And at some sites, we lost almost 100% of coral cover. And there has been subsequent bleaching events which have been less intense, and the most significant ones were in 2010 and 2016, where they also caused mass bleaching events in Kenya. And recovery has been very slow across the coastal stretch of Kenya. And in this graph here, the blue line shows the hard coral cover, and the green line shows the fleshy algae. We find that after the 1998 bleaching event, coral cover was really low, and the fleshy algae was occupying a bigger space. With time, there's been recovery, but as you can see, it's been variable. Sometimes it increases, sometimes it decreases. So the trend is not very pleasant. Yeah, so I was saying that the way the recovery is going on for the coral community is not pleasant, and we are operating at the edge of flipping to a phase shift. So it's very important to consider management actions that can help us be stable on this trend. And climate change is going to affect coral reefs in this century. And the recent IPCC report that came out last year, it showed that we are going to lose about 99% of coral reefs in this century. And if we operate at a temperature of 2 degrees centigrade above the pre-industrial levels, and if we can keep the temperature at 1.5 degrees centigrade above the pre-industrial levels, probably we could save about 30% of coral reefs. So this is the only window that we can use to save 30% of coral reefs in this era of climate change. And these would act as seed banks for repopulating coral reefs once we get the climate change issue regulated. And yeah, so they can act as seed banks for repopulating back the other coral reefs that we'll have lost. Next slide. So the sedimentation in Kenya, as you can see from this map, we have a lot of rivers coming into the ocean. And in this case, for coral reefs, it's mostly the River Sabaki that brings a lot of load of sediments into the marine protected area in Malindi and Watamu. And in the map to the right, we can see how also seasons influence the cover of sediments across different sites. So during the northeast monsoon, you find that it goes back, the sediments are stretched back to the north, and during the southeast monsoon, the sediments cover in a different direction. Next slide. In terms of pollution, we also have a huge amount of pollution coming into the ocean. And this is a study by Okuku and others where they monitored pollution for a decade. So this gives a clear picture of how different forms of pollution are distributed across the Kenyan coastline. And in this way, they have a direct effect to the coral communities that occur in the nearshore areas. Next slide. So lessons learned in management of pressures. In Kenya, coral reefs are mainly protected or conserved using the marine protected areas as a tool for management. And we have many marine protected areas that have different levels of management and also that were established across different time periods. However, these MPAs were established with the objective to protect and conserve biodiversity and ecological balance of marine ecosystems, which includes coral reefs. But during the mass coral bleaching event in 1998, we found that MPAs were not spared to bleaching, and there was similar colony mortality across all reefs, regardless of their protection. So this shows that as much as marine protected areas have been effective in conserving biodiversity, but in terms of the challenge caused by climate change, marine protected areas are limited to handle this kind of a problem. Next slide. So I would like to give an example of Watamu and Malindi Marine Park. These are the oldest marine protected areas in Kenya. And before the bleaching event in 1998, they were healthy reefs, one of the best in Kenya, with high coral cover and high structural complexity. But during the mass coral bleaching event, they were also badly hit and lost a lot of corals, reducing the coral cover and structural complexity. But because these MPAs are located near the Sabaki River, the addition of nutrients into the system and sedimentation, it made it very difficult for these reefs to recover from the impact. And we find that there's a study that said there was a phase shift during that time where these reefs were algae dominated. And it happened that there was a sea urchin boom during that time, which sea urchins are bioeroders. So they scraped off the algae from the surface, and somehow the coral managed to recruit and recover again. But the levels at this moment are not the same like before the bleaching event. So this is one of the areas where a very good MPA was highly impacted, and the recovery is very slow because of climate change. Next slide, please. So how do we put consideration for the marine spatial planning process in conservation of coral reefs? So MPA has been used as an important tool for conservation of coral reefs. And in this illustration, I show how it sits in the different levels of marine spatial planning. So we have marine spatial planning as this bigger process where MPAs is at a lower spatial levels within the MSP process. And then we have another level of zonation where we try to compartmentalize an MPA by developing different zones for different users. So within an MPA, we can have, for example, a totally protected area where no interference is allowed, and then another area where we could have tourism allowed, and other portions for different users. So in this way, we can design MPAs into different purposes, including a protection of coral communities. So next slide. There has been a great deal of effort in terms of increasing the areas of marine protected area all over the world. And under the Aichi target in 2010, it was the target was to achieve a 10% global marine protected area cover by 2010, and by 2020. And in this year, we find that we have a considerable effort that has been put. If you look at the chart on the right-hand side, we can see that still in the high seas, we have a very little area protected, under protection. Then in the EEZ, we have 3.5% protected, and in the coastal areas, which include mangrove, seagrass, and coral reefs, we have 7.2% of protection. So but there are some countries that have even exceeded the 10% cover and have gone beyond it. So, but the global picture is still it still needs a lot of work to increase the area of MPAs in our oceans. So under the SDG, we expect that by 2030 we will have the target is to have 30% of the ocean under MPA. So this offers a very important platform or opportunity in designing marine protected areas that are going to be climate resilient, so that during this era of climate change, we can still steer coral reefs through it and have a coral ecosystem even after climate change is not a problem anymore. So this brings to an important part in this talk, where I would like to talk about how can we move towards climate resilient MPAs. Next slide, please. Yeah, so recently we did some studies on the spatial patterns of coral communities, and also looked at the resistance and recovery potential of coral communities across the entire Kenyan coast. And in this study, here in the map, I show the areas that we focused on along the Kenyan coast. We partitioned the coastline into 3 geographic zones. We have the North Zone, which is the part B in red, and then the Central Zone is part C in blue, and the South Zone is the green, D. So the major findings from this work in terms of the spatial patterns is, we found that there is a marginal reef in the north, which is very important because from our study, we found that the coral community in this area, it is not well developed, because we have an upwelling area in the north, which makes a very high nutrient environment, and this limits coral growth. However, the little corals that happen to be there seem to survive bleaching events, because during the northeast monsoon, where the temperatures increase and other parts bleach, this area does not bleach because of the upwelling, which brings in cold water to the surface, and this cools off the water and enables corals to escape bleaching. And then, so it's a very important area that needs to be considered when we are designing climate resilient MPAs. And in the south, as previous talks have said, that it is a highly biodiverse area, and because it gets a lot of larvae from the south, and the currents, the East African coastal current transports larvae to the north of Kenyan coast from this zone. And so it acts as a very important area that supplies larvae to other parts in the north. So it has, there are implications on connectivity that need to be considered when we are designing MPAs. And the central zone, from our study, we found that coral communities in the central zone were similar to those in the north and to those in the south. But the coral communities in north and south were quite significantly different. So we find that Zone C could act as a potential of ecological corridor or a stepping stone for larvae as they as they get transported to the north. So there's important implication for conservation, and also as we make networks of marine protected areas. Next slide. And another part of the study that we did was to look at the spatial patterns in terms of resistance and recovery potential of reefs. And this was based on the ability of the coral communities to resist bleaching. In this way, if a community can resist bleaching, that means it's good, because we have the opportunity to, it has the opportunity to survive bleaching events. And if a coral community has the ability to recover from bleaching events, it's also an important area. And recovery in this way, I mean that it could have corals that can bleach and die, but maybe it is placed in a way that it receives larvae from somewhere else. So even if we get coral die-offs, and but larvae come into this place from other places, it still has the potential to recover. So this is also a very important area to consider for the planning of MPAs. And in this figure, we can see that the green is the resistance potential and the red is the recovery potential. We found that the resistance and recovery potential did not vary across the geographic zone. It was like uniform, but it varied across different habitats. So even within the North Zone, there was a lot of variation of the resistance and recovery potential across different habitats. So this shows that when we are talking about resistance and recovery potential of coral communities, it's based on ecological scales, ecological functional scales, and it's the geographic, or rather the biogeographic location becomes relevant. Also, in terms of the protection, we found that marine protected areas did not differ from other areas in terms of their resistance and recovery potential. So we realized that the current marine protected areas do not support, or rather they do not have the capacity to resist bleaching events, and therefore might not steer our coral reefs into the future in this time of climate change. Next slide. So in these graphs, it's just to reinforce the information that I have relayed in the previous map, that geographic zones did not have influence in terms of resistance and recovery potential. The same with different management levels. And next slide. Yeah, and these graphs just show how different habitats influence the resistance and recovery potential of coral communities across the entire coast. So we have different depths serving different functions in terms of resistance and recovery potential, exposure levels to oceanic waves, and also reef types. All these habitat factors, they have a high influence in terms of the resistance and recovery potential of coral reefs in Kenya. Next. So it will also be important to acknowledge the huge effort that is going on to increase protection through local management, local marine managed areas. This is a study that was done by Kawaka and others, and they show how the effort in terms of marine managed areas across the entire Kenyan coast. There are so many already, and these efforts are even becoming more, they are increasing. And as we are doing this, it will be important to also incorporate the aspect of climate resilience into these managed areas, so that we protect areas that can withstand climate change. Next. This is just a slide showing the different people that I used information from to generate this talk. Next, please. Yes, thank you.